Have you ever stopped to wonder what time actually is? We check our clocks, plan the future, reminisce about the past. But what if I told you that everything you think you know about time is just the tip of the iceberg? What if time can speed up and slow down? What if the past, present and future all exist simultaneously? In this video, we're going to uncover 20 shocking facts about time that will make you doubt reality itself. Get ready, because after watching this, your perception of the world will never be the same. We're about to start a journey that will totally blow your mind. Before we dive in, let's cover one crucial distinction. There is physical time, the kind measured by hyper-accurate atomic clocks, which seems universal and constant. And then there is psychological time, our internal perception of how quickly it flows. It's right at the intersection of these two concepts where the most incredible paradoxes are born. We're used to thinking of time as a river, flowing at a steady rate in one direction, from the past into the future. But modern science, from Einstein's theory of relativity to quantum mechanics, paints a completely different, far stranger and much more exciting picture. And today, we're going to immerse ourselves in it. So, fact number 1, the faster you move, the slower time passes for you. Let's start with a classic concept from Albert Einstein. Imagine the famous thought experiment involving two twins. One stays here on Earth, while the other blasts off into space, on a rocket travelling near the speed of light. When the astronaut returns, they will discover that their twin back on Earth has aged significantly more. This isn't science fiction. It's a measurable real-world effect known as time dilation. According to Einstein's special theory of relativity, the faster you move through space, the slower time flows for you personally. While this effect is only truly noticeable at incredibly high velocities, it is absolutely verifiable. For astronauts aboard the International Space Station, time genuinely moves fractionally slower than it does for us back here on Earth. After 6 months in orbit, they age about 5 milliseconds less. That's 0.05 seconds. While that difference seems negligible, this fact proves one crucial thing. Time is not an absolute unchanging constant. It is entirely relative, and it depends directly on your motion. Here is the second fact, one that directly relates to Einstein's ideas. Gravity slows time. Velocity isn't the only thing capable of warping it. Einstein's general theory of relativity states that massive objects, such as planets and stars, create gravitational fields that warp not just space, but time. The stronger the gravity, the slower time flows. This means that time runs slightly faster at the top of a mountain than it does at sea level. This effect is so real that it must be factored into the workings of global positioning systems, or GPS. GPS satellites orbit high above Earth where gravity is weaker. Time passes for them approximately 38 microseconds per day, faster than it does on Earth's surface. If engineers didn't correct this discrepancy, the navigators in our phones and cars would accumulate an error of several kilometers every single day. So the next time you use your navigation app, remember that you are utilizing direct proof that gravity truly slows down time. Let's move on to the third truly mind-bending fact. A universal now simply does not exist. We instinctively believe that the present moment is uniform across the entire cosmos. But the theory of relativity fundamentally challenges this. The concept of simultaneity is relative. Picture two observers moving relative to one another. Two events that one observer measures as simultaneous could, for the second observer, occur at vastly different times, one moment preceding the other. This implies there is no single cosmic present that uniformly divides the past from the future. Your now is uniquely yours. An alien in the Andromeda galaxy, travelling at a different velocity, has its own unique now, one that could potentially encompass events from what we consider our past or our future. This realization utterly shatters our intuitive understanding of reality, where we presume everyone is occupying the exact same moment. The fourth fact might make you question your own senses. What you perceive as the present is in reality already the past. Your brain needs time to process the information coming from your sensory organs. your eyes, ears, and skin. For instance, a light signal takes time to travel from an object to your retina, and then the subsequent neural impulse takes time to reach your brain. This entire delay averages around 80 milliseconds. In other words, you are constantly living slightly behind reality. The world you see right now is the world as it existed a split second ago. Your brain does an enormous amount of heavy lifting, synchronizing all these lagging signals to create a smooth and coherent picture of reality for you. But the truth is, we can never truly perceive the present moment directly. We are always looking at the immediate past. It's just like watching a live sports broadcast that has a slight delay. Our fifth fact explains why time seems to speed up as we get older. Remember summer vacations stretching out forever when you were a kid? Now the years just zip by. There are a couple of psychological explanations for this phenomenon. Firstly, for a 10-year-old, 1 year represents 10% of their entire life. But for a 50-year-old, that same year is only 2%. The relative length of each new period of time keeps shrinking. Secondly, when we are young, we are constantly encountering new experiences, first love, graduation, a new job. The brain actively records these vivid memories, making the time period feel richer and longer. As we age, life becomes more routine, and the brain stops documenting repetitive events in such detail, essentially merging them into one short interval. So if you want to effectively slow down time, just try more new things. So, what was there before time even began? Fact number 6 sounds paradoxical. Time itself originated with the Big Bang. According to current cosmological models, approximately 13.8 billion years ago, the entire universe was compressed into an infinitely dense and scorching hot point, known as the singularity. It was at that exact moment that the Big Bang occurred, giving rise not only to matter and energy, but also to space and time itself. This is why, from a scientific perspective, the question, what was there before the Big Bang, is fundamentally incorrect. It's like asking what direction is north of the North Pole. Before is a concept dependent on time. If time didn't exist, then the idea of before couldn't exist either. Time isn't some eternal stage where the drama of the universe plays out. Time is actually a physical property of the universe itself, and it was born right along with it. Why does time flow in only one direction? Our seventh fact connects this phenomenon to chaos. We see an egg break, but we never see the pieces spontaneously reassemble into a whole egg. This phenomenon is known as the arrow of time, and it is intrinsically linked to the second law of thermodynamics. This law states that in a closed system, the total entropy, a measure of chaos and disorder, must always increase. The universe as a whole constantly moves from order toward disorder. At the moment of the Big Bang, the universe was in a state of incredible order. All energy was concentrated in a single point. Since then, the universe has been expanding and cooling, and entropy has been increasing. This irreversible march toward chaos is precisely what we perceive as the flow of time, moving from the past into the future. If entropy could decrease, it's possible that time could flow backward. Fact 8 focuses on the realm of the impossibly small. There is a shortest measurable time interval known as the Planck time. It is defined as the exact time it takes for a particle of light in a vacuum to travel 1 Planck length, the smallest possible distance. This duration is approximately 10 to the power of -43 seconds. This moment is so impossibly brief it is genuinely impossible to conceptualize. To put it in perspective, in the time it takes you to blink, more Planck times have passed than there have been total seconds since the Big Bang. Scientists believe that at scales shorter than Planck time, our standard understanding of space and time completely breaks down. This is where the laws of quantum gravity take effect, and scientists are still struggling to fully comprehend them. Planck time is a fundamental limit, the absolute quantum of time, below which perhaps nothing can physically occur. Let's move on to some cosmic peculiarities now. Fact number 9. On Venus, a day lasts longer than a year. Yes, you heard that right. Venus spins on its axis at an incredibly slow pace. One full rotation, which defines a Venusian day, takes a staggering 243 Earth days. In contrast, the planet completes a full orbit around the Sun, a Venusian year, in just 225 Earth days. This means the Venusian day is actually longer than its own year. It remains one of the most bizarre features of our solar system. Scientists hypothesize that this extremely slow and notably retrograde, meaning backward rotation, might have been caused by a massive asteroid collision in the distant past. So, if you were living on Venus, you'd celebrate your birthday before the first day following your arrival was even over. Our 10th fact proves that the theory of relativity works even on the scale of your own body. Simply put, your feet are younger than your head. We've already established that gravity slows down time. Your head is slightly further away from the Earth's centre of gravity than your feet are. This means the gravitational field acting upon your feet is minutely stronger. Consequently, time runs a tiny bit slower for your feet than it does for your head. The difference is, of course, completely negligible, amounting to only a few femtoseconds over your entire lifetime. You'd never be able to notice or measure it without incredibly precise instruments. But the fact itself is stunning. It shows that Einstein's laws aren't just some abstract theory about black holes and deep space. They are operating right here, right now, on every single one of us, proving that even within the confines of your own body, time flows at different rates. Fact 11 turns every single one of us into a time traveller. Whenever you gaze up at the stars, you are literally looking into the past. Despite its incredible speed, light doesn't travel instantaneously. It needs time to cross the massive gulfs of cosmic space. Take, for example, the light from our nearest star, Proxima Centauri. It takes more than 4 years to reach Earth. That means when we see it, we are not viewing the star as it is right now, but as it was over 4 years ago. Now consider the Andromeda Galaxy, the closest major galaxy to our own Milky Way. The light from Andromeda has been travelling for 2.5 million years to reach your eyes. When you spot it through a telescope, you are witnessing light that left that galaxy when the very first human ancestors were only just appearing on Earth. Some stars we observe in the night sky may have already burned out and died long ago, but their light is still on its way to us. The night sky isn't just a photograph, it is an honest-to-goodness time machine. Fact number 12 involves our earthly clocks. Sometimes a calendar day doesn't actually contain the standard 86,400 seconds. Occasionally, scientists will add what they call a leap second, or coordination second, to our global time. Why is this necessary? The core reason is that the Earth's rotation is gradually slowing down, primarily because of the Moon's gravitational pull. As a result, the astronomical day, the time it takes the planet to complete one full spin, becomes slightly longer than the reference day measured by highly precise atomic clocks. To keep these two timescales synchronized, and to prevent our defined noon from eventually creeping into the evening, the International Earth Rotation Service decides to insert an extra second. This addition typically happens either on December 31st or June 30th. During this moment, the time that normally follows 23 hours, 59 minutes and 59 seconds does not immediately jump to midnight, or instead, the clock briefly displays 23 hours, 59 minutes and 60 seconds. Fact number 13 explains why time seems to stretch out when you're facing a crisis. Many people who have been through accidents or other life-threatening events often report that everything played out in literal slow motion. Scientists call this phenomenon tachypsychia, or psychological time dilation. Of course, time itself doesn't actually slow down. This incredible effect is entirely created by your brain. In moments of extreme stress or fear, your brain shifts into a hyper-alert state. It begins processing far more information per second than it normally would. The amygdala, the region of the brain responsible for memory, instantly becomes overactive, meticulously recording every single detail of the environment. This intense density of recorded memory means that when you later replay the event in your mind, it feels like it lasted much longer than it did in reality. Essentially, this is a powerful survival mechanism. designed to give you extra perceived time to react and increase your chances of making it out alive. Fact number 14 introduces one of the most bizarre concepts in modern physics, the block universe theory. The hypothesis proposes that the past, present, and future exist not sequentially, but simultaneously. To visualize this, imagine the universe as a gigantic four-dimensional block where three dimensions define space, and the fourth dimension is time. Within this block, every single event is already recorded. Everything that ever was, is, or will be. From the Big Bang to the final heat death of the cosmos, it is all already there. Our consciousness simply moves along the block's timeline, like the beam of a flashlight, illuminating one moment after another. This linear progression gives us the subjective illusion of the passage of time, and crucially, of free will. However, from the perspective of the block universe, the future is just as real and unchangeable as the past. It is a radical concept that transforms time from a dynamic process into a single static landscape. Let's dive into the quantum world for fact number 15. Particles can literally borrow energy from the future. While this sounds like science fiction, it's a direct consequence of one of quantum mechanics' fundamental laws, the Heisenberg uncertainty principle. This principle states that we cannot simultaneously measure both a particle's exact energy and the precise duration it holds that energy. This loophole allows particles to momentarily violate the law of conservation of energy for an extremely brief instant. As a result, they can spontaneously create so-called virtual particles that exist for only a negligible fraction of a second before vanishing. This process, known as quantum fluctuation, is fundamental to many phenomena, including quantum tunneling. Quantum tunneling occurs when a particle passes right through a barrier, even if it doesn't possess enough energy to classically overcome it. It's essentially taking a quick energy loan from the future to make the jump and then immediately paying it back. Fact number 16 takes us back to our planet. The Earth's day is actually getting longer. Billions of years ago, when life first started here on Earth, a full day lasted only about 6 hours. Since then, the days have been steadily increasing in length. And the reason? Our constant companion, the Moon. Its gravitational pull creates the tides here on Earth. The friction caused by the tidal bulge dragging across the ocean floor acts like a brake, gradually slowing down the Earth's rotation. This process is still happening right now. Every century, the Earth day lengthens by approximately 1.7 milliseconds. This is a very slow change, but over geological timescales, the effect is massive. During the time of the dinosaurs, for example, the days were shorter, meaning there were roughly 370 days in a year. So, if you constantly complain that 24 hours just isn't enough time in a day, just wait a few million years and your wish will finally come true. Fact 17 takes us deeper into a fascinating new form of matter, time crystals. Conventional crystals, like diamonds or salt, are defined by an ordered structure of atoms fixed in space. Their atomic lattice repeats across 3 dimensions. In 2012, Nobel laureate Frank Wilczek hypothesized that crystals might exist whose structures repeat not just in space, but also in time. By 2016, scientists successfully created these crystals in a laboratory setting. Unlike conventional objects, which settle into a state of rest at their lowest energy level, the atoms inside a time crystal are in constant periodic motion, yet they consume or release absolutely no energy. They essentially tick with their own intrinsic rhythm. This groundbreaking discovery could lead to the development of ultra-precise clocks and the next generation of quantum computers. Fact number 18 is a classic of the time travel genre, the grandfather paradox. This is a famous thought experiment that highlights the logical contradictions inherent in travelling to the past. Imagine you built a time machine, went back in time, and killed your grandfather before he ever met your grandmother. If that happened, your father, and consequently you, would never have been born. But if you were never born, then who travelled back to commit the murder? This creates a logical inconsistency, a genuine paradox, or a vicious causal loop. Fortunately, there are several fascinating hypotheses attempting to resolve this problem. One is Novikov's self-consistency principle, which suggests that any action you take in the past is already part of history and cannot fundamentally alter it. The other is the multiverse theory, which posits that by changing the past, you don't destroy your own timeline. You simply branch off and create a new parallel reality. Fact 19 debunks yet another one of our intuitive assumptions. The universe has no temporal center. We often think of the Big Bang as an explosion that happened inside an already existing space, one that must have had a specific center. But that visualization is incorrect. The Big Bang was the expansion of space itself. Thus, the universe has no geographical center. In the same way, it lacks a temporal center or any sort of master time reference point. There are no master clocks or a cosmic clockmaker whose timepiece dictates the one true universal time. As we've already established, time is relative and its flow changes depending on speed and gravity at different points in space. Every single point in the universe has its own unique temporal history. All clocks, wherever they are located, are equally valid. This powerfully underscores just how flexible and deeply strange the very fabric of space-time truly is. And finally, the 20th fact, one that connects physics directly to our own psychology. Your memory is, in a sense, a time machine, the ability to mentally travel through time. That is, recalling the past and imagining the future is one of the most unique features of human consciousness. Neurobiologists have discovered that both of these processes are managed by the same network in the brain, the so-called default mode network. When you recall yesterday, your brain reconstructs the sequence of events. When you plan a vacation, it does the exact same thing, but with hypothetical scenarios. This capacity allows us to learn from past experience and build plans, which is a key factor in our survival and development as a species. So, essentially, every single one of us is a born chrononaut, constantly travelling along a mental timeline. So, what did we learn today? Time isn't just a simple arrow moving forward. It actually warps depending on speed and gravity. Our now is, in fact, the past. The past, present, and future might all coexist simultaneously in the hypothetical block universe. Time itself might not have even existed before the Big Bang. Each of these 20 facts isn't just some entertaining piece of trivia. It's a key part of a massive puzzle that forces us to rethink the universe and our place within it. Perhaps time is the greatest mystery of all. Thank you so much for watching all the way to the end. If this video blew your mind as much as it did mine while I was researching it, make sure to hit that like button and subscribe so you don't miss our next deep dive into the unknown. Now for the big question. Which of these facts about time fascinated you the most? Or perhaps you have your own theory about the true nature of time? Let me know in the comments below. I always love reading your thoughts. Until next time.